Hi, everybody. This is Soumya, and I'm professionally a web developer by now. And I've had a code experience of 2 years in both coding as well as mathematics on an online edtech on an online platform, which is from the company White Hat Junior, which is the edtech company. And apart from that, I'm also post that I've done an internship of 6 months in code in the web development, and I've done almost like 1.5 years as a SharePoint developer, which also comes under the web development area. So my hobbies are uh, to learn new recipes. I'm recently married, so I'm just looking for recipes. I haven't been I don't know cooking much, so I've been looking for cooking recipes more. And apart from that, I also love to do coding, mathematics, and yeah, um, I also love to listen to music. Music is the one that heals me and calms me down. So yeah, this is a quick short intro about myself. Today, I'm gonna start talking about a topic which is quadratic equations. Why quadratic equations is it has always been my favorite, the equations and the geometry part. And of course, the trigonometry is also my favorite. So these are the aspects that I love the most. So this is something that I would like to talk about. So that's the reason I've you know yes, I've chosen this topic. This has been like one of my favorite chapters from the school as well. So I'm a average student by in normal, but my maths used to be on the top for every single time. So maths is my one of my favorite subjects. So I would like to share my screen, and I would like to start a topic. I've written a notes and taken out images out of it. So I'll just show those images and try to explain today's class. Okay. So considering I'm into the class now. Hi, children. Hi, everybody. This is Soumya. Today, I am your maths teacher. So, today's topic is about the quadratic equation. What quadratic equation is? Okay. So, to understand that, let me just write on the board. So, I hope you guys can see my screen. Just a second. Everything is not getting shared is something that I'm looking for. Just a second, please. Mhm. So I hope you guys can see my screen now. Yeah, yes, everything is visible. So, okay. So students, today we are going to learn about quadratic equations. Now, if you guys have remembered, in the previous sessions or the classes, we have learned about polynomial. Let's revise quickly. Okay. So, uh, a polynomial is represented something like this. That is, P of x is equal to an x power n plus an minus 1 x power n minus 1 plus so on. Okay. And this is, and these an minus 1, an minus 2, a2, a1, a0, everything are the coefficients of x to the power of n, x to the power of n minus 1, and so on. And these are also known as constants. Constants are nothing but they belong to a number, only a number. Okay. And this is a representation of real numbers. I hope you guys have already learned about it. And in any polynomial, the highest degree term is never a zero. The constant is never zero. Anything else can be zero. Okay. This term the highest term, the first term of the polynomial can never be 0. Okay. So here the n represents the degree of it. Okay. Now, and each of them are called terms. Okay. This is called a term. This is called a term. This is called a term. So each and every combination of a n x bar n, a n minus 1, x bar n minus 1, they are called terms. Now, a polynomial of a degree 2 is called a quadratic equation. Now, what is meant by a degree of 2? Let's understand that. So, can you see here, there is a x to the power of 2, right? So, as I said, the number represents the degree. Okay, here the number represents the degree of it. And now we just saw that this is something we want. Okay, this is 8x to the power of n, right? So if that n is equal to 2, it is called a quadratic equation. Okay, so that means a2 x2 a1 x bar 1 plus a equal to 0. So this is the one thing is called a quadratic equation. Now let's understand better using the next one. So let's define it. Okay, what is the definition of the quadratic equation? An equation with one variable. Okay, if you have seen in the previous page as well, there is x, only x. It is only one variable. We are not using x, y, z, different variables. An equation with one variable, which highest power of the variable is 2. X to the power of 2, right? If the power is equal to 2, then it is called a quadratic equation. And it is usually represent. So these are some of the examples. 2x square plus 3x plus 4 equal to 0. X square minus 4 equal to 0. 4x square plus 5x equal to 0. And so on. You can see. Now, let's understand what are the roots of the quadratic equation. Okay. What is the standard form of it? How it is represented? Actually, it is represented in the form like this. That is ax. Can you see here? Yeah, ax square plus bx plus c equal to 0. This is written and where a, b, c are constants. That means they are real numbers. But in the real scale, 0 is also a constant, right? But here a should not be equal to 0. Why a should not be equal to 0, ma'am? Because here, if a is equal to 0, then any number multiplied with 0 is also 0. So 0 into x square is equal to also 0, right? If 0 equal to also is 0, then the definition over there, which is on the top, I'm just sorry, just let me clear all the drawings first. Yeah. So what we said for the definition, we said that the highest power of the variable should always be 2. So to remember that, a should never be equal to 0. If a equal to 0, it is not a quadratic equation, right? Any doubts till now, my dears? Anyone? Perfect. Let's go to the next one then. Okay. So this quadratic equation gives us two values. Okay. Because the power is equal to 2. You know, the power of the quadratic equation equal to 2. So it gives us two values to us. And these two values are called roots of the equation. Okay. Let's understand what are the roots of the equation. Okay. What are they? Okay. Before even understanding the roots, I mean, how to find roots, what are roots? Roots are nothing but if you solve the value of x from the equation, we get two values. Those are called roots. Okay. Now, there is a third important concept. Till now, we have understood two concepts. One is the standard form of it, and another, a quadratic equation have how many roots? Two roots. Okay. And if the highest degree of the of the polynomial is equal to 3, then you'll have 3 roots. If you have the highest degree as 4, how many roots you'll have? 4. So the roots are dependent on the highest degree of the polynomial. Okay, let's go. We have to learn about one of the important concepts that is discriminant. Now, what is discriminant? Let's understand. Okay, so this discriminant is generally denoted by D, capital D. Okay, in a quadratic equation, what is quadratic equation now? You guys tell me along with me. Ax square plus bx plus c equal to 0, where a, b, c are constants, and don't forget about the and a not equal to 0. Good job. Clap for yourself now. Good. Now, what does this d means? Okay, d is nothing but b square minus 4ac. What is this? So basically, this is an equation or an expression. No, I'm sorry. This is an expression. B square minus 4ac is an expression which is used to understand the nature of the roots. Now, we are not even understanding discriminant, and now you're talking about nature of the roots. Basically, the roots can be, okay, real or imaginary. Okay, so why this is important is to understand the nature of roots. Okay, what is the nature of the roots? We'll understand. Okay, this is one of the important formulas we will explore in 2 minutes. Just give me 2 minutes. We'll cover the last concept and we'll go inside. Okay, deal? No one will forget. What is discriminant? Discriminant is equal to, what is the value of the discriminant? B square minus 4ac. Now, what are the types of the quadratic equations we have? We have the normal one, which is ax square plus bx plus c, and the one which has only 2 terms in it, which is one is the square term and other one is the power of the first term. That is called adfected quadratic equation. Now let's understand that. Okay, so that means the one which, if an equation just has ax square plus bx, okay, if the equation just has ax square plus bx and doesn't have any c, then it is called adfected quadratic equation. Okay, now what if you have ax square plus c, but you don't have a first term of the equation, okay? That is bx. Then it is called a pure function, or it is called pure function. Let's go. Okay, now, as I promised, the nature of the roots, okay? So basically, the nature of the roots can be classified into 3 major things, okay? 3 major ones, all right? Yeah, let's change the color to red. Okay, we'll understand better. And I would like to draw. Yeah, let's go with this. And let's draw a shape of a rectangle. Nature of the roots are these 3, real and equal. The roots can be real and equal. The roots can be real and unequal. And the roots can be imaginary. Okay, these are the 3 types. Okay, so if it is real and equal, that means our discriminant is equal to 0. Whenever we calculate the discriminant, we will understand the nature of the roots. Okay, so that means if the value is, okay, if the nature of this value is b square minus 4ac is equal to 0, then they are real and equal. b square minus 4ac greater than 0, they are real and unequal. And if b square minus 4ac is less than 0, it is imaginary. Now, ma'am, what is real and what is imaginary, right? Let's go ahead and understand that. The real number is that every rational and irrational number, whatever you see on the scale is called a, which can be measured, or you can tell on your real scale, a real time scale, 0, -1, -2, everything you can tell. Those all numbers are called real numbers. Now, what is imaginary numbers? Imaginary numbers are the numbers which you can't, which are not measured. They haven't been known to anyone. Okay. So, for example, if I tell the root of -7, see, a square root of negative number, square root of a 4 is 2. But square root of -4, that is something imaginary. Okay, that is something called, we call it as an imaginary. I hope you guys understood till this part. Anybody, any doubts, please raise your hands now. Okay. All right, everybody know now? Okay, let's understand. Let's quickly revise what have we learned till now. Okay, standard form. Second is what? Second one is, everybody forgotten. Huh? Not good, not good. We are learning now. Chalo, let's go. Second is, what are roots? Okay. Then we understood about the discriminant. Then we understood the types of it and how to calculate the nature of the roots. Okay. And the nature of the roots are classified into how many parts? 3 major parts. What are they, my children? Good, real and equal, real and unequal, and imaginary. Perfect. Now theory is done. Let's get into calculations now. Okay. Let's understand examination. Let's examine the nature of the roots. Now, whenever the roots, this equation is given as 5x square minus 6x plus 7 equal to 8. Initially, whenever it is given as examine the nature of the roots, we need to understand that we need to find the discriminant of it. Nobody would ask to find the discriminant of it. Okay? They'll ask, what is the nature of the roots? So for that, what we have to do? We have to find out what is b square minus 4ac. If this value is equal to 0, then the roots are real and equal. Good. If it is less than 0, they are imaginary. If it is greater than 0, they are real and unequal. Okay, let's go. So, we have compared this with our standard form. So, we got to know a is equal to 5, b is equal to -6. If you guys can see here, just a second. Just selecting the pen. So if you guys can see, this is -6. Okay, not just 6, it is -6, and c is equal to 7. My bad, just c is equal to 7. Okay, now we have written the same values. Now let's calculate the discriminant. Okay, b square minus 6 square minus 4 into a into c, right? 4 into 5 into 7. Okay. Now, just a second. So 6 square is 36. So -1 square. -1 into -1 will be +1. Right? Remember? So any square of a negative number is again a positive number. So using that, it is 36 minus 4 into 5 into 7. 4 5s are 20, 27s are 140. Okay, so that gives us -104. Okay, And we have known from our nature of the roots that if b is negative, the roots are not real. That means the roots are imaginary. Got it? Please note it down, and if you have any doubts, do let me know. Chalo, let's go further. Okay. In this one is a different way. Okay. We are posing a question, and along with that, we'll understand a new concept also. All right. Interesting. Chalo. Now, first we have to find, here is the question. Find the value of m if the roots of the following quadratic equations are equal. Oh, now they are not asking about the nature of the roots. Children understand, they are telling that the roots are already equal. Now, what to do when they are equal? Okay, let's see. When they are equal, that means from the nature of the roots, we know real and equal means discriminant is equal to 0. Good job. Good job. Chalo. So the equation is something like this. Don't fear. Okay. We'll understand. We know the standard form, right? So what is the standard form? Ax square plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. From that, we can assume a is equal to 4 plus m, right? Because x square is there. And b is equal to m plus 1, c equal to 1. Okay. Since the roots are equal, b square minus 4 is equals to 0. Right? Now, let's go ahead. What is b? M plus 1. So, we are writing m plus 1 plus 4 into a is 4 plus m. Because it is the expression, we are putting in a brackets now. Okay? Into 1. Now, 4, 1. Now, this is a square plus a plus b whole square, right? So, we are using this formula. A square, a plus b whole square is what? A square plus b square plus 2ab. Perfect, perfect. Now, so using that, I am expanding this. M square plus 1 square plus 2 into m into 1. Okay? Chalo. Minus 4 into 4. I have multiplied 4 ones, which is 4. 4 ones are 4. And I should multiply that with 4 plus m. So I've done this. Okay. Chalo. Now, if we go ahead, now we'll have to understand that m square plus 1, m square will be m square, 1 square, 1, right? 2 into 1, 2. 2 into m will be 2m. Okay. 2 times of anything will be 2 of that variable, right? So 2m minus this, we have to first multiply minus 4. Never multiply with just 4. Okay, because it's a negative number, we have to multiply with that negative number. Okay, not just 4, minus 4. 4. Normally 4 fours is 16, but because we have one minus, we'll write minus 16. Okay, and minus 4 into m would be minus 4m, right? Now, after this, m square will be m square. Because we have 2m expressions, we'll solve them. Okay, 2m expressions are there, we can solve them. So plus 2m minus 4m, which gives us minus 2m. Okay, plus 1 minus 16 minus 15. Okay, till here anybody is having doubts? No, right? I would request you to note it down till here. Okay, now the big question comes: how to solve this and find the values, right? If you remember, if we solve this, this is called the, this gives us one basic, I am sorry, just a second. Yeah. If we solve this, we'll understand how to find the roots of it. Till now, we just understood the nature of the roots. Okay? Chalo. Now, to do this, what one has to do is, yeah. So what we have to do is, here, we have to do the factors of AC. Okay? What is A and what is C? Don't ask that question, okay? So in the previous equation, we had m square, okay? M square minus 2m, okay? 2m minus 15, right? M square minus 2m minus 15 equal to 0. Okay? So the A is 1 and C is minus 15. Okay? Okay. The C is 15. Let's understand. Okay, so let's find the factors of 15. 15, what are there? 1 15 is a 15, and 3 5s are 15, and 5 3s, again 5 3s is 15, and 15 1s are 15. So there are 4 factors, and in the 2 combinations, 1 and 15 and 3 and 5, right? Now, what we have to do is, we have to factorize them. What do you mean by factorization, ma'am? So basically, this we should manipulate in such a way that the values will become, okay, I mean, if you plus and minus, add plus minus, manipulate the middle term to get again minus 2m. So what did I do here is, I'm taking 3 and 5, okay? Why did you choose 3 and 5, ma'am? Let's understand this. Even if I put plus 1 and minus 15, I'll get plus 1 and minus 15 as minus 14, right? If I put plus 15 and minus 1, plus 14. But here, what I want, I need to put get minus 2, okay? So for that, what I've done is, I've taken 3 and 5 now. I've put minus 2. So the greater number should be having minus. So that's the reason I've put minus 5, and the lesser number with plus, which is 3. So I have changed this to m square plus 3m minus 5m minus 15 equal to 0. Okay. So I've break down the middle term in a AC manner. Okay. The middle term. Okay, in the AC manner, okay? Because here A is equal to 1, that's the reason directly we have taken 15. Else we should take some like multiplication of A and C, okay? We'll ignore the signs now. I mean, we should keep it in the mind, but currently what we also have to check is, when you multiply these two, are they equal to the C? When you multiply plus 3 into minus 5 is equal to minus 15. Yes, 3 5s is what? 15. So plus 3 minus 5 equal to minus 15, right? So we have to consider that. Now, let's take common from these two. Okay, from these two, if we take common, m is common in these two. And if we take common from this, minus 5 is the common part, right? So if I take an m plus 3 minus 5 into m plus 3. Now, if I take common m plus 3, I'll get m minus 5, right? M plus 3 I've taken. So the remaining part would be the common part of it. Now how to solve, how to get the values. There is one beautiful theory that we have gotten, that is zero product rule. Okay, what does the zero product rule says is, zero product rule says whenever the product of two expressions, are they expressions individually? M plus 3 and m minus 5 individually. Okay, they are expressions because they are not equal to 0 now. If whenever the product of two expressions, are they in the product? It is multiplication, right? It is multiplication only. Product of two expressions is 0, then at least one of the expressions is 0. That means if any two expressions product is equal to 0, that means any one of them must be 0, right? If you multiply any two of the numbers and if one number is 0, then automatically, so if the answer is 0, right? If we are saying this, both multiplication is equal to 0, this might be 0 or this might be 0. So from that, what we are doing is we are dividing, okay, into LHS and RHS. That means we are giving 0 to this expression and the other expression also, okay? So m plus 3 equal to 0, m minus 5 equal to 0, which gives m equal to minus 3 and m is equal to 5, which overall answer is m minus 3 or m equal to 5. All right, then let me just quickly go to the next question, okay? So to understand this is again a good question. Why? Because now we can get to see A is not equal to 1 now, right? If A is not equal to 1, we would have directly taken this, right? Even before going here. Now understand, is it in the quadratic equation? Ax square plus bx plus c equal to 0? No, right? Let's change that to the standard form. Because it is in the RHS, 39 is in the RHS. When we bring 39 into the LHS, it becomes 2x square minus 7x minus 39 equal to 0. Now, this would have happened, okay, if A is equal to 1, but this is no longer used anymore, okay? This is not valid, okay? And if you really want to check, you won't even get the variables also, okay? You won't even get the value also, okay? So if you want the difference to be 7, right? So never, if you want 13 minus 3 would be 10. So it doesn't make sense. So this is wholly a wrong one. Now 13 twos is what, sorry, 39 twos is what, 78. Now let's find out the factors of 78. 1 into 78, 2 into 39, 3 into 36, 6 13s is 78. Now I need the difference of 7. I mean, I need to get the number 7, right? I need to take 1 plus and 1 minus. Okay, it is usually plus and minus most of the time. Okay, I have to do some jugad. At last, I have to keep this part as not as multiplication. This part is addition. Okay, and when you multiply both of them, those values should be equal to this 30. Okay, so let's see. These both will just give me 37. This both will give me 23. And this both will give me 7. Right? The difference is 7. So that's the reason we'll go with this. Okay. All right. So it is -7, not a +7. Negative means the biggest number should have negative number and the smallest number should have positive number. In the previous one, I have told that the multiplication should be equal to AC. Okay, I've just talked about C, but actually it is AC because A was 1. I didn't talk about it. So we should always check the factors for A and C and is it meeting or not. If you see now, 13 6 is 78 and 39 2s is also 78. because this is minus 39, so minus 70. Okay, chalo. Now I'm just rephrasing it. 2x square plus 6x minus 13 minus 39. And if I bring 2x common in this too, I'll get x plus 3 and minus 13 if I take common, it is, sorry, x plus 3. My bad, it is x plus 3. Okay, x plus 3 equal to 0. X plus 3, if I take common in both of them, it will be 2x minus 13 equal to 0. So using our new rule, that is zero product rule, what does it say? It says that whenever the product of two expressions is equal to 0, then at least one of the expressions is equal to 0. Okay, so according to that, we'll make this expression equal to 0 or this expression equal to 0. We'll put both of them and we'll get the value. So hereby, therefore, okay, the x values are equal to minus 3 or x is equal to 13 by 2. All right. And that's all, my dear viewers, for this class. I hope you understood it. And in next session, we'll get to know more about a simple technique. There is a formula to find the roots, not the factors, but another way. Okay, I'll let you know. Okay. So meanwhile, I want you to complete the exercises that we have provided today regarding the nature of the roots, and using the zero product rule, you have to find out the roots. Okay. So, all right. Have an amazing day. Bye-bye. So that's my short intro of about quadratic equations. And today I would also like to tell that I'm interested in joining the RSA Academy, because I've gone through the website and I've gone through the vision and mission of the RSA Academy, and I totally agree with the mission of it, that you can, I'm sorry, just a second. Yeah, you can be who you want to be, right? So, and I truly am I am interested in taking up this opportunity to explore and make kids learn maths in a very fun way. And if there are any effective methodology that one can opt for, I would like to learn from my fellow teachers as well, because at the end of the day, the students are my first priority. They are the ones who need to understand. And yeah, that's it for my day. Thank you so much. I hope to hear from you guys soon. Thank you. Bye-bye.